Hey, science enthusiasts. Picture this: light, the fastest thing in the universe, clocking in at 299,792 kilometers per second, suddenly stops dead in its tracks. Sounds like something out of a sci-fi movie, right? But it's not fiction. Scientists have actually figured out how to freeze light, and it's one of the wildest breakthroughs in modern physics. In the next 5 minutes, we're going to unpack how they pull off this incredible feat, what it means for the future, and why it's got everyone from tech geeks to dreamers buzzing with excitement. So, buckle up, let's dive into the dazzling world of frozen light. Before we get to the freezing part, let's talk about what light actually is. Light travels at an insane 299,792 kilometers per second. That's 186,000 miles per second, fast enough to zip around Earth 7 times in the blink of an eye. It's made up of tiny packets of energy called photons, which are basically the universe's speed demons. They never stop, never slow down, unless something extraordinary gets in their way. In a vacuum, nothing can touch them, and even in air or glass, they barely lose a step. But scientists said, challenge accepted, and came up with a way to not just slow light down, but stop it entirely. How? It all starts with some seriously cold science. So how do you stop the unstoppable? It begins with atoms, think rubidium or sodium, cooled to a temperature so low it's almost unimaginable, near absolute zero, which is negative 273 degrees Celsius. That's colder than the void of space, colder than anything you'd find naturally on Earth. Scientists use lasers and magnetic fields to trap these atoms and slow their frantic vibrations to a near standstill. When they get this cold, something bizarre happens. The atoms stop acting like individual particles and start behaving as one unified, super strange blob. A state called the Bose-Einstein condensate. It's like they've turned into a single quantum entity, and that's where the magic kicks in. Now, when a beam of light hits this condensate, it doesn't just zip through like it normally would, it slows way, way down. We're talking from light speed to as slow as 17 meters per second, slower than a kid coasting on a bicycle. But slowing it isn't enough for these scientists. To fully freeze it, they use a second laser, called a control beam, to tweak the condensate just right. At the perfect moment, they switch off that control laser, and boom, the light's energy gets trapped inside the atoms, locked in place like a paused video. They've held it there for up to a second, then turned the laser back on, releasing the light to continue its journey as if nothing happened. It's like giving light a memory. This isn't just some theoretical pipe dream, it's already happened. Back in 2001, a physicist named Lena Howe and her team at Harvard made headlines when they slowed light to a measly 17 meters per second using a sodium-based condensate. That was wild enough, but then they took it further and stopped it completely for a fraction of a second. Since that breakthrough, researchers around the world have been building on her work, pushing the boundaries of what's possible. Today, they can hold light for a full second or more, and each experiment brings us closer to turning this crazy idea into practical tech. It's proof that science can take the impossible and make it real. Okay, so why should we care about frozen light? For starters, it could supercharge quantum computing. These next-gen machines use quantum bits, or qubits, to process data at mind-boggling speeds, and trapped light could act as a memory system, making them faster and more reliable. It's not just computers, though. Imagine ultra-secure communication networks where messages ride on frozen photons, impossible to hack. And what about storage? Picture saving your entire movie collection or music library in a beam of light instead of a clunky hard drive. This isn't just cool science, it's a glimpse into a high-tech future that's closer than we think. Let's dream big for a second. What if we could freeze light for minutes, hours, or even days? Could we use it to manipulate time, store massive amounts of energy, or build sci-fi gadgets like cloaking devices? Okay, maybe that's a stretch, but that's the beauty of science. It starts with wild ideas and turns them into reality. Freezing light is just the beginning, and who knows where it'll take us next. So, what do you think? Are you as blown away by this as I am? Drop your thoughts in the comments, hit that like button if you're excited, and subscribe for more mind-bending science adventures. Until next time, keep shining.